Hi everyone. In this video we're going to continue with the model that we found in the previous video, and we're going to answer some of those questions that are a lot like the previous homework assignment. So this is really good practice and maybe review if you already feel like you've tackled that well. The first one I've got in here is reasonable domain and the associated range. And this can be a little bit tricky at first, especially the associated range piece. So we want to think about what's reasonable in this situation. And then we want to make sure that the domain and range match. That's kind of what the associated piece is implying. So we're thinking about the number of hours that you might spend weightless and your reaction time. And I would say that I can right away cut the H off at 0. I don't want to look at negative numbers of hours spent weightless. So we're going to start with you haven't been weightless at all, continue from there. In terms of a maximum for this one, I don't know, and I don't expect you to go research like how many hours you could be weightless and how long your reaction time can get. So in this one, I think I'd actually leave it here. Usually you can kind of cap on the other end if you've got, I don't know, like temperature. We know that the temperature outside is not going to get to 200 degrees, things like that. But here I think I really would just leave it there. What I don't want to see is you just looking at your data set and saying, okay, the biggest piece of data I have is for 14 hours, so I should chop the model off at 14 or 15 hours. You shouldn't just assume that that limits the situation. It does mean we won't trust our predictions quite as much when we get very far outside of that, but it doesn't mean the model doesn't work at all outside of there. So here's our model. If we're going to start with H equals 0, that means that we're also picking our starting T value. So this point was 0, 0.157, and again, that's just coming straight out of slope-intercept form. This would be my intercept. So if your H values are greater than or equal to 0, your T values are greater than or equal to 0.157. If you know something about reaction time and you want to say, I know it can't be more than, I have no idea, say 2 seconds, you could cap that. I wouldn't argue with you on that. That's fine. But just make sure you then cap your H's at the same point. So if you decided I'm going to cap right here, you would need to make that your biggest H value and your biggest T value. So there's room for some interpretation here when you're doing domain and range. You might know something I don't know. You might not know something I know. That's okay. If you think I'm going to not understand your thinking, just write out a quick sentence for me to let me know why you chopped it off there, and I'll be totally happy with that. Okay, next is to interpret the slope of the model. So our slope is 0.135. And I'm going to put that over 1, and that's rounded, and that's completely fine for our interpretation purposes. Interpret is the same thing as when I ask you to explain using everyday language. So remember that this is change in T, which was in seconds, over change in H, which was in hours. So this is telling me that my reaction time will increase by 0.135 seconds if the number of hours spent weightless increases by 1. So I'm seeing there reaction time increases by 0.135 seconds per additional hour spent weightless. Okay, next is interpret both intercepts of the model. We already have one of them, the 0, 0.157, so we can go straight to interpret for that. It looks like before spending any time weightless, reaction time was about 0.157 seconds. For the other intercept, we will actually have to find that. So I'm going back up to my model. Here, I'm going to change colors. Let's do a little bit of scratch work here. To find the H-intercept, like our X-intercept, we would have to let T equal 0. So we're going to set this equal to 0. And we'll have to do just a little bit of solving. So we're going to subtract the 0.157 from each side, and then we can divide by the 0.135, And in that case, what I'm seeing, even without going and crunching that number, is that this is going to be negative. So we're getting into that negative time spent weightless. So the meaning of that would be that to get reaction time of 0, you'd have to have negative hours spent weightless. But this has fallen outside of our reasonable domain. So either say that, or you can tell me what it would mean and then just state that that's not a reasonable thing. But do be careful if you didn't pick a good domain and what you're getting here actually makes perfectly good sense. That means you should check your domain, not that you shouldn't interpret that point. So do be thoughtful if that happens. Next part, what is the reaction time of an astronaut who's been weightless for 3.5 hours? Okay, so we are being asked to plug in 3.5 for H. So I went T of 3.5, and that formula was 0.135 H. So H is getting replaced by 3.5 here, plus 0.157. So this is basically just calculator work on this one, and then we'll want to remember our unit. I calculated 0.6295 with that. We can just give that whole number, or you could round it off a little bit if you want to. All right, and you could also be asked to find an H value given a T value. So just really think about which variable you've been given, and you should be in great shape. All right, thanks for watching.